Okay, I hear a lot of conversation about those first couple of problems, or I guess there's a whole bunch of them there in part one. Let's work through those ones in part one together. So that, because you're gonna have a couple of these on your test. This is not a practice test, okay? This has more on it. But I put extra practice for these first few because you need to practice. All right, so I heard some questions being asked. And some of the questions were, this is for, can we just cancel? Can we just cancel out a sign? Can we cancel 5 into 25? And the answer is no. No. You can't. The only way you can cancel when you've got subtracts and adds is if you can cancel the whole thing. You can't cancel part of an addition expression. So what did anybody notice about the numerator? Anything?
Difference of squares?
The difference of squares. So sine plus 5, sine minus 5. Now, can I cancel?
Yeah.
Yes, because that and that are the same. So you've got to pick up on the difference of squares. All right, now what about the next one? Nothing cancels. Do not cancel at this point. What do you notice though? The difference of squares in the denominator? So how does that factor in the denominator? Cotangent plus 3, cotangent minus 3. And now you can cancel because you're taking out the whole thing. Be careful when you write your answer. It's 1 over cotangent plus 3. When you cancel the whole thing out, there's like a 1 there to hold the place. So that one's 1 over cotan plus 3. Got it? One more, same thing. What are you going to do at the top? Factor it into what? 10 minus secant, 10 plus secant. Please leave them in the order they are. If 100 comes first, you got to do 10 minus and 10 plus. And then the denominator is secant plus 10. These are being added, so it's the same. It's only the subtraction one that's got to be in the right order. The addition one is right. So the answer is 10 minus secant x. That's what you're going to draw a circle around, right? Got it? Hi?
Does it matter which side, like 10 and the second, third?
It has to be 10 minus secant.
Yeah.
It has to be. I just got done saying if the 100 comes first, you got to do 10 plus and 10 minus. Okay, were all three of those problems kind of similar?
Yeah.
Okay, so when we see something that looks sort of like that, we're going to think about factoring the difference of squares, right? Okay, now, the next ones don't look like that. The next ones look a little different than that.
Are you going to be able to use our storage?
No.
No, okay.
No. At this point, we need to know what these things are. And it's not that much. Sine is sine. Cosine is cosine. What's cotangent? Cosine over sine. Yep. Now, I want you to listen real carefully. You are in the habit of canceling, and that's good. That's a good habit. But you can only cancel when you're multiplying. You see that right there? Do not even think about canceling that sign with that sign. You can only cancel if it's multiplication. Okay? So what I have here is sine over 1 plus cosine squared over sine. Because cosine times cosine, 1 times sine. Now, what am I going to do with that? Get a common denominator. 2 fractions added. What's my common denominator? So this one needs to be multiplied top and bottom by sign. This one needs nothing. It already has what it wants. So now I've got sine squared over sine plus cosine squared over sine. Can I add those together now? So now I have sine squared plus cosine squared all over sine. Wait, what's sine squared plus cosine squared? 1. 1. That's 1. So I have 1 over sine, which is cosecant. Now I'm going to skip down to F, because F is the exact same kind of problem. So I'll come back and get E in a second, but F is exactly the same problem. Okay, now, what am I going to do here? Sine over 1 times sine over cosine plus cosine over 1. Does anything cancel? Can't cancel because of the plus sign. So I'm just going to combine these. What does this make? They're multiplied. What does this make? Sine squared over cosine plus cosine over 1. Do not cancel. You cannot cancel when there's a plus in between them. So what are you going to do since there's a plus in between them? You're going to combine them by getting a common denominator. This time, the denominator is going to be cosine. So now we have sine squared over cosine plus cosine squared over cosine. Oh my gosh, this looks really familiar, doesn't it? So when I put them together, this time I'm going to have sine squared plus cosine squared over cosine. Yeah. And what's sine squared plus cosine squared? 1. So now I have 1 over cosine, which is secant. Are the 2 problems we just did, D and F, very, very similar? Yeah. Yeah. Very similar. All right, and then we'll go ahead and do E, then I'll have that whole section done. So E, now, what's the good news about E? There are no pluses or minuses. So what does that mean? Cancel away. Now, do you remember that cotangent is cosine over sine? So I changed that one. And then secant is 1 over cosine. And then tangent is sine over cosine. Now, because it is all times, you can start canceling things. So The sine squared and the sine squared will cancel.
The cosine.
The cosine and the cosine will cancel, and the cosine squared and the cosine squared, oh my gosh. Sine? Is that all that's left?
Yeah.
You okay with that? Okay, now, that's probably the hardest part for most of you, right? That first section. Is that the hardest part? No, what's the hardest part for you then?
Triangles.
Okay, so all the rest of it's triangles, so when you say the triangles are the hardest, what does that mean?
Just remembering the things, like
They're kind of the formulas, yeah.
formulas.
Law signs and law
Like
cosines?
knowing when to use them.
Yeah.
Okay, well, that actually is a pretty easy thing, Gabe, to tell. Look to know whether to use sines or cosines, because look at 2A. 2A, the problem says how many triangles are possible. So I can go ahead, I'll figure that out in a second. But as soon as I look at this picture, I know it's a law of sines problem. If you can't do that, if you can't draw a circle and have two numbers in it like that, then it's not gonna be a law of sines problem. It'll have to be law of cosines. It's one or the other, always. So if I had a triangle where like this is 58, this is 6, and this is 7, I can't draw that one and have two numbers. I can't draw this one and have two numbers. See, I'm drawing the angle and its side. And I can't do this one. So that's gonna have to be a law of cosines problem. You have to be able to have that match in the problem if you're gonna do the law of sines. Otherwise, you're doing law of cosines. Okay, everybody clear on that? All right, let me go ahead and finish this problem since I drew it up here. This one is how many triangles are possible. So you're not solving it all the way. You're just figuring out if there's 0, 1, or 2, right? So here we go. Sine 29 over 18 equals sine C over 16. So let's cross multiply, divide, and type it into our calculator and see if we can all do that. Because that's what you're gonna have to do tomorrow, or whenever we take our test. I think it is tomorrow.
It is.
Please don't just copy down what I wrote. Make yourself do it by yourself. Tomorrow you gotta do it by yourself. And everybody write the proportion for the law of sines. And then you know, as soon as you write the law of sines, you know you're gonna cross multiply. And then in this case, does everybody see you're gonna be dividing by 18? Because sine C is a unit, stays together. So dividing by 18 gives us something that looks like this. If you go ahead and type that in, you can, but it's going to be a decimal. And remember, you're not looking for a decimal, you're looking for an angle. So you don't just type that in, you second sign that, and that will give you the angle. Are you with me?
No.
So what did did you get when you second signed 16 sine 29 divided by 18? 25.53. Now, do you remember that sometimes when you type that in, you get error?
Yeah.
And that means there are no triangles. You did not get error here, you got an answer. So now you figure out, okay, could I have the same exact triangle, but have a different angle C that is 180 minus the first one? So 180 minus the number that's on your calculator, that would be 154.47. Now, can I have a triangle with a 29 and a 154 in it? No, doesn't that make more than 180? So this triangle didn't work, or that angle didn't work, which means only one did. So how many triangles are possible? One. Now, is there anything about that you have a question about? Roxy? It's always 180 minus the first one. 180 minus the first one. So when you type this in, second sign, if there's a second answer, it's going to be 180 minus that answer. Okay? The angles of a triangle have to add up to 180. 29 and 154 is 183. Is that possible in a triangle? No. So that one doesn't work. This one does. Right? Okay, what else is hard for you? I'm not going to be able to do the whole sheet for you, but we'll do what else is hard for you? What else do we need to practice? On the sheet here that's left.
The length, dividing it.
Which one?
Number 4.
4 is a parallelogram problem. Guys, every practice test had a parallelogram problem, right? This thing that I just wrote last night has a parallelogram problem on it. Guess what? Your test is going to have a parallelogram problem on it. Okay, now, I don't know whether you'll have to find a diagonal, find the area, or both. But those are the two skills we have to be able to do. So I drew it this time for you. Probably on the paper it will say you have a parallelogram with sides that are 10 and 11 and an angle of 23. So that's your picture. Find the longer diagonal. Now, am I drawing this diagonal? Or am I drawing this diagonal?
That one.
That one. As soon as I draw that in, this angle becomes useless to me. I don't know anything about it anymore, other than the whole thing is 23. If that whole thing was 23, how big is this one up here? What's the relationship between these two? They add up to 180, so this would have to be 157. I heard somebody say it, 157. The adjacent angles of a parallelogram are supplementary. They add up to 180. Yes, they add up to 180. The adjacent angles do. Now, I am finding X. I want to find the length of the longer diagonal. Right? So I need to use either the law of sines or the law of cosines. Okay? Unless it's area, kids, those are the only things we've done. Law of sines and cosines, that's it. So what is it in this problem? gotta be cosines. Because if I look here, I don't have both. If I look here, I don't have both. If I look here, I don't have both. That's a triangle. So my law of cosines has an x squared out here and a cosine 157 out here. And then what's in the middle? 10 squared plus 11 squared minus 2 times 10 times 11. Somebody tell me what you got for the length of the longer diagonal.
423.51.
Okay, now that's x squared. Remember in your equation, that's x squared. So it's 20.58 actually, right? 20.58 inches if we round it off to the nearest hundred. The directions on the test will be rounded to the nearest hundredth. I guess I didn't put rounding on here, but. Okay? That's the diagonal. Now the second part of that question says find the area. Well, let's just look at what I've got up here. Could I find the area there? The triangle area will be 1/2, 10, 11, sine 157. The only time we use cosine is in the law of cosines. So don't ever use cosine for anything else, right, on this test. Just the law of cosines. Now, I'm going to type that in. Is that going to be the answer to the question?
No.
No, because that is just the area of the triangle. So how will I get the area of the whole parallelogram? Multiply it by 2. So for area, I got 42.98 square inches. 42.98 square inches. Okay? All right, what else is hard for you that we haven't done yet? What else do we need to look at?
Hexagon.
Number 5, find the area, this is area now, find the area of a regular hexagon inscribed in a circle. So what's hexagon mean? 6. And it's inscribed in a circle with a radius of 19. Now remember, when you draw your picture, the radius has to go to a point of the hexagon. Don't be drawing it here, that's not a radius. This is a radius. So I'm going to go ahead and draw another radius. I'm finding the area of this thing. What do I always do after I get this far? What do I always do next? Find my angle, and I find my angle by doing 360 divided by however many I have. So since it's a hexagon, I have 6. So this is a 60 this time. Kylie, you with me? So the area of the triangle will be 1/2 1919 sine 60. Right? And then I need to once I get that area, I need to do what? multiply this one by, not by 2, by 6. I got 6 triangles in this problem, don't I? So I got 937.91
Yeah.
square feet. Okay?
Would that be your final answer?
That would be my final answer. That's the area of the hexagon. Roxy? 360 divided by 6. Always 360 divided by 6. You remember that, right? That's how we do it. We're gonna have to do it tomorrow. But it might not be divided by 6. It's divided by whatever you got. That's what a circle is, right? 360 degrees. Alright, what else? Huh? 37. Leave your phone here. Alright, who else has something that's hard for you? Olivia?
Number 3, letter
3C. Find the area. Now, this is the harder area problem because why? What's wrong with 3C? You do not have enough sides. Alright, so I'm doing 3C now. So if you need to be paying attention, you probably better. I cannot find the area of this triangle because I do not have enough sides. If I do what I just did here, I need 2 sides and the included angle, or I need all 3 sides. I do not have that, so I gotta find a side. Might start with finding this angle. Remember, anytime you have 2 angles, go ahead and fill in the third one, even if you don't need it, go ahead and fill it in. So what would this third one be? 89. Now, Gabe, what do your beady little eyes spot right here?
Law sign.
Law signs. So sine 89 over 16 equals, now you get to pick, right?
Yeah.
Maddie, what are you doing, honey? Are you doing this? Yeah. Okay. So, what do you want to do? Olivia, what do you want to do? Sine 38 over whatever that is. I didn't label it, so I'll just call it X or A or P or Q, whatever you want to call it. Okay, everybody?
Yeah.
So now, I'm going to cross multiply. So X sine 89 equals 16 sine 38. Now what do I divide by? I'm solving for X.
Sine 89.
So I gotta divide by sine 89. Right?
Yeah.
And I'm gonna type that in on my calculator. So 16 sine 38 divided by sine 89. And it gives me 9.85. Would anybody agree with that? Now, don't get excited and put that in the answer blank. That is not the answer. We wanted the area. So now I have these 2 sides, right? So I'm going to use that angle, the one that's in between my 2 sides. So the area is 1/2 16 9.85 sine 53. Olivia, you got it? And then I just type it in. So 1/2 times 16 times 9.85 times sine 53. And I got 62.93 for the area of that column. you have to use the angle that is between the sides. Here are your sides, Olivia. What angle is between them? 53. You have to use the included angle.